Hello, everybody. Good morning, good evening, good afternoon. I keep saying this, but I think this is specifically for the European time zone, so it's probably going to be good morning for most of people watching now. So, hello, everybody. Hello, Martin. You're muted, I think. Oh, no.
Hi. Yes, I
Yeah,
wasn't. I was muted on purpose.
on purpose.
I was telling the robot lady to turn off the heater.
I see. Good.
Yeah.
Yeah,
Welcome
should be
everybody.
freezing.
I hope you are all well this morning and excited to learn more about Neo4j and graph databases.
Yeah, absolutely. I'm looking forward to this workshop session again. On Neo4j fundamentals. So it's really going to be a good one today. I see people from all over Europe as expected. So UK, I see Spain, I see France, I see Stockholm, so Sweden, more Spain, Greece, more UK. So great to see you all. Thank you for joining. Thank you for participating today. Thank you for your interest in Neo4j fundamentals workshop. It's going to be a mix of hands-on and learning, listening exercise. So that's what we're going to do today. We will guide you through, and mainly Martin will do that. If you have questions, please use the big marker Q&A segment. There you can type in your questions. I will have a look for those questions, and we have a couple of spots in the workshop today where we can answer those questions. I can read them, and then we can answer them live on stage. Some questions maybe we can answer directly in chat, but primarily please use the Q&A segment for that, so that we can you don't lose questions in chat, because sometimes it scrolls by quickly and then I don't see them anymore. Just use that. If you have any other issues, just type away and let us know. If you are wondering what's going to happen with this session afterwards, or if you missed something, if something went by a little bit too quickly, we will record the session. We will share the video with you afterwards. We will also share the links or all the other material with you afterwards, so you can continue on your own. Basically, if you just start today, or if you just wanted to listen today what Martin is doing, and then you want to do it yourself afterwards on your own time, you're welcome to do so as well. It's it's all possible. So do as you like, do as you prefer, and don't worry if something you miss something. You can always go back in time, basically, by clicking on the video recording from this session today. And yeah, I think that's what I wanted to say about the logistical bits. I'll be around for Q&A parts and for other issues if they should be arising. But Martin, you are the star of the show today.
Well, I don't know about that, but thank you very much. Just a couple of other logistical things to note is obviously we're streaming this to multiple places, and I have lots of screens. So if you see me do this is because I'm looking at Alex. If you see me do this is because I'm looking at Big Marker. So I am looking at you. I just happen to be using multiple screens because this will be, a practical workshop. There are going to be lots of opportunities for you to join in and have a go. You don't need anything other than a computer or a laptop and a browser. So anyway, I wanted to start with just a little bit of an introduction in terms of who I am, and I'm going to try and use Neo4j to do this. I am Martin O'Hanlon. I am a person, perhaps as you would have already realised. And there is a node in Neo4j that represents me, and I can expand the relationships from that node, and we can learn a little bit more about me. So first of all, I work at Neo4j, and Neo4j's mission is to help the world make sense of data. I work at Neo4j as a technical curriculum developer, and I created this course or workshop, this Neo4j fundamentals workshop. And we can use our graph to learn a little bit more about Neo4j. Neo4j was founded in Malmö, which is a city in the southern part of Sweden, and we're also located in other places around the world, including London. I work with somebody called Emil. Emil was also the founder of Neo4j. Neo4j is a graph database, and we are going to learn a lot about graph databases and about Neo4j. And if you want to find out more, you can go to neo4j.com. And if you're interested, where you will find, oh, hang on, let me just you will find lots of blog posts and links to documentation. And you will also find Graph Academy, which you'll find at graphacademy.neo4j.com. And this workshop or course or webinar, however you want to describe it, is sort of part of our training offering, and you can find lots and lots and lots more training at Graph Academy. So I am just going to switch the screen that I'm sharing to go back to my notes, which I think is this one. Excellent. All right, lovely. Okay, great. So that's a little bit more about me. In terms of what we're going to be doing today, we're going to be looking at concepts. So looking at graph concepts and graph databases. We're going to be doing a little bit around data modeling. We're going to be exploring lots of data. We're going to be looking at Cypher, which is a query language, and we're going to kind of reading, writing, and aggregating data. And we're also going to be doing some data importing as well. And as I kind of said, if you take one link away from this, it should be graphacademy.neo4j.com, where you will find lots and lots of really great material to help you. And this session is a sort of abridged version of about 4 fundamental courses on Neo4j, where you can dive into a lot more detail. So what I really hope is that all of you will follow along with this session today. And there are 2 important links that are worth noting. One is a download, a zip file that's got some data that we're going to use as part of our exploration and as part of our learning today. And the second one is to register for Neo4j Aura. Neo4j Aura is Neo4j's cloud solution, and you can have a free Neo4j Aura instance running in the cloud in a matter of moments. So that's my aim today, is to get you all up and running with the Neo4j database, being able to use Neo4j data importer to create a database. And at the end of the session, you should feel comfortable loading your own data into Neo4j and running Cypher statements. So, but in order to do all of that, we are going to go ahead and create a Neo4j Aura instance. So hopefully, Alex is putting links in the chat, which is great news. But yeah, if you want to download this zip file and click on this link to register for an Aura console, which is what I'm going to do now. So, and by doing that, by going to that link, to that second link, you should find yourself at Neo4j Aura. And I'm going to go through the process of signing up for an account in the same kind of process that you would do, and create a Neo4j Aura instance. So I'm going to go through this process. First thing I'm going to do is I am going to quickly sign up for an account. What's the date we're doing this? It is the 2nd. And that's because I've missed the important piece. But yeah, if you go ahead and create an account, and obviously you can log in with Google or with any other SSO that you might have or is supported. So I'm going to go ahead and create my account. And it's going to ask me to verify my email, which is what I am going to do now. And I've just realized I will just go and do that. And again, if you've got to that point, you should receive an email from Neo4j, which says, please verify your email address. And you can go ahead and verify your email. And you should be presented with a screen once you've verified your email, that looks a little bit like this one, where you agree to the terms of service. So once you have agreed to the terms of service, we should be presented with the Aura console. This is the console, and here you can create Neo4j instances, you can import data, and you'll see there's a collection of tools as well, allowing us to explore data, create queries, see metrics, logs, etc. So a quick look, see how people are getting on. I'm going to assume that there are no questions, so everyone's happy. Anyway, so once we have created and we've logged into Neo4j Aura, we can create an instance. And by creating an instance, we have a few options, including a free, professional, and business critical. We are going to use the free one. So I just clicked on free there, and it's going to give me the credentials for my Neo4j instance. So I am going to copy that and put that into my secure, obviously, password manager. Excellent. And you can also download the credentials as well, and you'll get a small kind of text file with your credentials in them. Obviously, keep that file safe. It has important information in it. So let's just see where we are. Excellent. So hopefully we have got to the point where we can see Neo4j is creating our Aura instance. This will take a minute or two, and what we're going to do is we're going to move on at this point and continue with the workshop while Neo4j is creating our Aura instance for us. So I just need to quickly switch back to my presentation, which is somewhere. One of my many windows that I have open. It is this one. Excellent. So let's spend some time talking about graphs and what graphs are and why they're useful. So graphs are incredibly useful when you need to understand the relationships between entities. So, for example, how two people are connected, or maybe you have a problem whereby you've got a hierarchy of employees and you're looking for people, but you don't know the depth of where that person might sit within a hierarchy. Or you're looking to explore things like bills of materials, and you don't know where a particular part might live within the relationships of all the other parts, or you need to calculate a route between two places. And when I say graphs, I don't mean these. These are charts. What I mean are graphs that look like this. So circles and lines, edges and vertices, nodes and relationships. That's what I mean by graphs. And graphs essentially consist of nodes, and we use these nodes to represent things. They represent entities. And in this case, it's a movie, but it could be a product, a car, a location, something physical. Yeah. Nodes represent things. And we can identify the things, or the groups of these, or we can categorize these things using labels. So this node represents the movie Toy Story. And nodes can also have more than one label. So, for example, this node represents the movie Toy Story, which is an animated movie. If we look at a different use case, you could have a node that represents Martin that we saw earlier. I'm a person. I'm also an employee, so on and so forth. And nodes can have properties such as title, released, plot, anything else you can think of. And properties are stored in Neo4j as key value pairs with a key and a value with a type that is relevant to the property that we are storing. Now, the power of graphs comes in the relationships between data. So we have our movie Toy Story, and we have the actor Tom Hanks. And we would have a relationship between the movie between the actor Tom Hanks and the movie Toy Story. Relationships connect two nodes, and only ever two nodes. And relationships have types. In this case, the type of the relationship between the node Tom Hanks and the node Toy Story is Tom Hanks acted in, that is the relationship type, the movie Toy Story. Relationships also have a direction. In this case, Tom Hanks acted in Toy Story. Toy Story didn't act in Tom Hanks. And relationships can also store properties. So, for example, the role that Tom Hanks played was that of Woody. And the key thing to kind of note about when thinking about graphs as a kind of data as a data store is relationships are real things in the graph. And this is a kind of key difference between relational databases, where relationships are abstract. They are they're not real things. They are the existence of a primary key and a foreign key. Relationships in a graph are real things, and you can store data against them, as we can see here. So, why? Why? Why would we worry about using graphs? And I think the important thing to note, and I will talk about it lots and lots of times, is why graphs are useful, or when graphs are useful, is when the relationships are as important as the data itself. And that's when graphs become really powerful. And I think, if we just sort of think a little bit back to, from, the early part of our career, we sort of like, when we're introduced to technology and we're introduced to data storage, we condition ourselves to think in terms of rows and columns, whether that's a relational database or a CSV file. And, tabular data is that tried and tested methodology that works for most use cases. And we represent data like this. So this is an ERD diagram of users, movies, roles, directors, people. And tables are easy to read, and we can get data out of them, and we can also make instances of tables that are created purely to deal with relationships. So, for example, the ratings. The ratings tables, the roles and the directors are there to facilitate that idea of many-to-many relationships. And herein lies a problem, particularly when we're thinking about relationships. And it's each of these foreign keys, when we're traversing a relationship between, in this case, between one table that could be users and movies and the ratings that users give them, each of these foreign keys is backed by an index. And as the size of the table grows, and as the index grows, these queries become slower and slower. And for many use cases, that's not an issue. But if you are looking to understand relationships in data, the more tables you join, the query will become exponentially slower. And there's a couple of questions that you sort of might find yourself asking yourself, which is, are you struggling with complex database schemas? Is your database schema full of link tables to represent many-to-many relationships? Is your schema becoming large and unwieldy? Are you struggling with poorly performing database queries? Are your database queries very complex, containing lots and lots of joins? Are they struggling or taking a long time to return results? And do you store things like hierarchical data or complex networks? Do you need to analyze the connections in your data rather than just the data in the table. And it's these sorts of problems that are typically graph problems and are probably better supported with a graph than a table. And this is a statement I like, which is, graph databases are designed to efficiently store and query complex networks of nodes and relationships. And graph databases are designed from the ground up to efficiently handle highly connected data sets, from the underlying data storage right up to the query language. The role of graph databases and of Neo4j is to handle that highly connected data in an efficient way. Okay, so hopefully what we're going to do now is we are going to import some data into the Aura database that we just created. So I just need to find the right window again. And what we're going to do is we are going to import some movie data. I will just show the links again. So you're going to need to download this movie data file. Sorry, I keep clicking on the screen. From dev.neo4j.com/ga-movie graph, and you can register for a Neo4j instance in the Neo4j console. I am just going to download that zip file. And we can go back to our Aura instance. Here it is. Share this tab instead. And while we have been talking, Neo4j Aura has created a database for us, and we can see right now that it is running. So our first task, and what we're going to do now, is we're going to import some data into our empty Neo4j database. Right. So there is a set of data services here. We can see that there is a service called import. And what import allows you to do, or the data importer allows you to do, it allows you to import data from existing relational databases or from flat files into Neo4j. And we are going to go through the process initially of loading a model that I have created, importing some data so we can explore the data, and then a little bit later on we will modify that data model to incorporate some more data into the graph. So the first thing I'm going to do is I'm going to create a new data source. This is where my data lives. Now in this case it is in a set of CSV files, and it's in that zip file that you just downloaded. And this is what data importer looks like. And as I said, later on we will look at importing or modifying how we import data. But we have on the left hand side a data model, and then we have in the middle have on the left hand side our data sources, and in the middle we have our data model, which is how we want to represent our data in Neo4j. But I have already created a model which is in that zip file you downloaded, and if we use the menu in the top right hand corner, there is an option to say open model with data. That's what that zip file that I asked you to download contains. It's called movie-fundamentals.zip. And if we open that, it will open a model for us and incorporate a number of data files, which are these CSV files. And this is the model that we are going to create. It has a person node, and it has a movie node, and it has two relationships, acted in and directed in. And if we click on each of these elements, we can see some configuration that says, where do I get that data from? Well, you get it from person.csv file. And how am I going to map properties within the node? But it's all been set up for you. What you need to do is just run the import, and that is going to ask you, well, what instance, where do you want to import it to? In this case, we've only got one instance. It's the one we just created. So I can connect to that. and it's going to run the import. It's going to happen pretty quickly. It's not a particularly big set of data, and we can see that it has imported data from this set of files into these nodes and these relationships. Excuse me. Once we have our data in, we can use the option to explore the results. And what this is going to do is this is going to open up the explore tool, which is commonly referred to as Bloom. And it's going to show us a graph of the data that is in our Neo4j database. And if we zoom in, we will be able to see the nodes that we have created. In this case, I've zoomed in and I found Woody Allen. Woody Allen has a label of person, and he has a property called name. And if I double click on any node, but in this case, the node for Woody Allen, it is going to open up and show me the properties of that node. So we can see that this node has a bio, property, born in, IMDb, name, poster, a TMDB ID, a URL, so on and so forth. And we can see from the graph that there are two relationships between the node Woody Allen and another node, which is a node representing a movie. It's got a movie label with a title, Mighty Aphrodite. And again, if we click on that node, we can see that this node has a series of properties that are representative or stored against that node. And again, if we click on a relationship, so this is the acted in relationship, we can see again that there are properties stored against the relationship. And again, in this case, it's the role that Woody Allen acted in the movie Mighty Aphrodite, which was Lenny. Explore will also show us some information about that relationship in terms of what the start node is, what the end node is, and some information about those nodes as well. Okay, so before we move on, I think this might be an opportunity just to see if there have been any questions.
Yeah, I think that's a great time. Excuse me. There was two questions. There were two questions actually. One from Lucille. They asked, because you mentioned the database should be or the data should be highly connected when considering a graph database. Do you have examples where a graph structure is not needed, or where a graph database would be like in the opposite way? Where do you think a graph database is not the right choice?
I personally believe, as an employee of Neo4j and an advocate of Neo4j, that graphs are everywhere. And actually, I do believe that. However, if I'm going to go, like what's the opposite of highly connected data? A list of transactions. No. A list of transactions that basically say money came in, money came out, and you're not interested where that money came from or where it went. You just list of account numbers. Money in, money out. That would be I suppose the opposite extreme, where actually a table of data is a perfect choice for a transactional list. Yeah.
I think that kind of not really a follow-up question, but I think also kind of like where does a graph database not really fit is Boyan's question. They ask, can you import other data than text data, like pictures, sounds, movies, things like that?
So I suppose there is no MP4 data type within Neo4j. You could, however, obviously store your data somewhere else and provide a link to it within a property within the graph. I don't know whether the question is inferring towards vectors and embeddings though. I'm going to assume it is. Just sort of say, actually, if you wanted to create an embedding for a piece of text and have a vector index to allow you to find similar text, you could absolutely do that within Neo4j. There is support for vector indexing and embedding types, or lists of numbers.
Could be it. Could I mean, if you think about this as a store for movies or pictures or something, that this is not it. I mean,
Yes. Yeah.
yeah. If
Yeah.
this was the question, then not really. Like Martin said, if you have metadata information, vectorized information about your movies, sounds, images, whatever you have, then definitely this is a good choice for it, because of the enrichment and all of the other things you're gonna see what the graph brings. But if you just want to store, you need a place where you put your MP3s, and don't put them in a graph database.
Yeah, exactly.
And there was one more question, but I think you probably we will cover this. Mike asks, how would you search for Woody Allen if you don't discover him by accident? I think
we will absolutely do searching for data. Yeah. Yeah, this is what we're looking at now is just our explore tool. It allows you to visually look at data, and it's a good way to sort of like start with navigating through a graph and understanding the structure of a graph as well, which is obviously significantly different to a traditional relational database or other NoSQL databases as well. Okay, so let's use that as a kind of opportunity to segue. So I am going to find my slides again, and we are going to look at Cypher. So Cypher is a query language, and we'll absolutely, I think it was Mike, allow you to search for Woody Allen. I think my examples use Tom Hanks, or maybe I can't remember what actor they use, but we'll perhaps change them for Woody Allen. So let's start with some definitions. So Cypher is a declarative query language that allows you to identify patterns in your data using an ASCII-style syntax of brackets, dashes, and arrows. We are going to explore what this means. Let's just sort of note a couple of words, though. So declarative. So we describe what we are looking for, not how to get it. So if you're used to SQL or other sort of database query languages, they are declarative query languages. You describe the data that you want or the action that you want to take rather than how to do it, which is obviously different to your general purpose programming languages, Python, Java, etc., where you describe how to do something, not what you want. And again, Cypher is a declarative language. This particular pattern here, where we have person, acted in, movie, will find person nodes that have an acted in relationship to movie nodes. So let's break that down. I've done this bit when we were just talking. So it allows you to identify patterns through this ASCII style syntax. So let's just have a quick look at that. So brackets. Brackets represent nodes. I'm quite a visual person. Brackets, or parenthesis if you would prefer, are round like the edges of a node. And then within the brackets, so within the node, we can include information about the node that we're looking for, such as its label. We can use dashes and arrows. We can use dashes and arrows to describe relationships. And within square brackets, we can include information about the relationships that we are looking for. In this case, the relationship type. Sorry, you have to excuse me. I have a bit of a sore throat. You can include within the square brackets information about the relationships that you are looking for. And obviously arrows dictate the direction of the relationship that you're looking to find. Finally, we can define variables. So this is how we refer to the elements that we found within this pattern. So this pattern finds the person nodes, the acted in relationships that have a direction to the movie nodes. And we can define variables, in this case, P, R, and M, which is how we refer to the particular elements within that pattern. And we're going to explore this and see how we do that. Sorry, excuse me. So let's say we want to read some data from Neo4j. And the way we do that is we match a pattern. We find a pattern in the database, and we use that using a keyword called match. So match says, find this pattern. We can also filter. So we can filter on properties. This says no property. In this case, it's filtering on the movie title. So this will filter it to only show the movie nodes where the title is equal to Toy Story. And then we can choose what to return. So we can return nodes of properties and properties of nodes or properties of relationships. So that is the sort of general structure of a query where we are looking to read data from Neo4j. So again, if you're sort of familiar with SQL, the match is the equivalent of the sort of like from join. Really what we're saying is, what's the source of our data, where is where, and return is select. So where filters, select says these are the things that I want. Okay, so let's have a look at some examples. So I am going to go back to my Neo4j Aura instance. We're still on Explorer at the moment. And I'm going to use the query tool. So the query tool is, I suppose, the default tool that allows me to query a Neo4j database and return some results. I'm just going to zoom in. Hopefully you can see that a little bit better. The tab that I just closed, along here you can see some information about your database. This is sort of saying how many nodes we've got, what relationships we've got, and what properties we have as well. But here I can write a query and I can return it. So let's just start with that very simple match clause. So I want to find some data. So when I say match, I need to provide it with a pattern, and a pattern can be as complicated as sorry, excuse me. It can be as complicated as multiple relationships and multiple nodes, or as simple as a single node. So I can say match all the person nodes and return them. So I'm saying this is my pattern, which is match nodes. We can tell that by the brackets. The information that I'm giving it says only match labels, nodes that have the person label. Any nodes that you find, define to the variable P, and then finally return that. And if I run that, what I'm going to get back is I'm going to get back a graph of all of the nodes in this graph that have a person label. They're not connected in any way. All I've done is just matched the nodes, which is a great place to start. And I could, for example, say, include a filter that says where p.name, so where the name property of the person node equals, say, Al Pacino. And if I run that, I'm going to get one node back. There is only one node within our database that has a name property of Al Pacino that also happens to have a person label. And back to Mike's question, if I wanted to search just for Woody Allen, I could write a query to do that. And there is Woody Allen. So let's just expand on that. The other thing that I can do when creating a pattern is I can include data that I want the pattern to match on as well. So previously I used a where clause. I could also use curly brackets and define a property that I want you to match on as well. So Al Pacino, and then return Al. And again, I get a similar result. But what I've done is I have expressed a pattern not only includes labels, but also includes additional information that I would like you to match as part of that pattern. So now I have a pattern that returns one node, which is Al Pacino. We can also create patterns that include data. So let's say I want to find the movies that Al Pacino acted in. Sorry, excuse me. So I can use the acted in relationship to find the movies that Al Pacino acted in. The relationship goes between person nodes and movie nodes. So I'm going to express my direction, and I'm going to. So to recap, I'm matching one single person node because there is only one that has a property of Al Pacino. I'm then using the acted in relationship to find other nodes that have a movie label. And I can return Al and then R and then M. So in this case, I'm returning the one node at Al Pacino, all of the relationships, and all of the movie nodes. And if I run that, we get back a graph. We get back a graph that has the Al Pacino node, the relationships that he has to movie nodes. And we can take this idea of pattern matching further. So I don't have to just use single, node relationship node. I could also say, okay, well, let's use that acted in relationship again, but let's use it the other way to find the people who acted in the movies that Al Pacino acted in. So this is the people who acted in the movies that Al Pacino also acted in. And now I get back a more complicated graph. So it starts from Al Pacino, which is the single person node we matched at the start. Let's call that the anchor node. It uses that acted in relationship to find the two movies that Al Pacino acted in our database, and then uses that acted in relationship again to find the movies. Sorry, to find the people who acted in the movies with Al Pacino. Yeah. And at the moment, we are returning nodes. So we're just returning, the node that represents Al Pacino, relationships, nodes that represent movies. But we can also return tabular data by expressing the properties of those nodes that we want. So I could return. So if I say name, so I'm going to return Al Pacino's name. I'm going to return the title property of the movies that Al Pacino acted in. And then I'm going to return the name property of the people that acted in the movies with Al Pacino. And now I get tabular data, which is Al Pacino, the movies, and also the people that acted in those movies with Al Pacino. So I think let's take a couple of questions, Alex, because I think after this, I have a few challenges for people to do.
Challenges, that sounds good.
Yeah, we like a challenge.
Yeah. So we have a couple of questions
Sure.
coming in. So I'll read them off, and then we can see if other questions are coming as well, and then we see where we go. So the first question is from Georgios. Georgios asks, how would you incorporate temporality on the nodes and the edges? If there is entity changing over time, what is the best practice? I think it's a bit of a more advanced question at this stage. I don't know if we won't be covering this in
Yeah, I mean, we won't be covering this in this particular session. However, there's nothing to stop you doing the same techniques that you would in data warehousing by including date time properties to allow you to do effective from, effective to, essentially. Yeah. Okay, before we move on to other questions, Alex, I'm really tempted to kind of get people having a look at these challenges, having a go, writing some queries, and then perhaps when people are having a go at those queries, we can answer some questions. So I have 3 challenges for you, and I have 3 Cypher queries for you to have a look at. So the first one is I just want you to find a movie. Find a movie you like, right? So there's a simple match clause here that does that. And then the second challenge I'd like to have a go at is to use the acted in relationship to find who acted in the movie that you just found. What I've done here is the question marks are things that you need to fill in. So there is a missing movie title here, the one that you found. There is a missing relationship here, so on and so forth. And then the third challenge is there is a directed relationship, which between movies and people that describes who directed that movie. Lovely. Alex, should we do questions while people are having a go? Can we leave this?
Yeah, let's leave this open, and I'm not going to change the view. Next question comes from Lucille. Lucille asks, "What are the top three? What are the top three?
The top 3.
Yeah, top 3 best practices when writing Cypher queries."
I'm not sure I can come up with 3. I think my tips, given what we have known, what we've learned so far, is if you are looking for specific data, match an anchor node. So match a node directly, one particular node, and then use relationships to find other nodes based on that anchor node. I think that would probably be my first one. And there's, typical good practices: only return data that you need. So, you saw me returning like a whole graph of data, including like all the nodes. It's not typical that we would need all of the data about a node. So, just return the properties that you need. And I suppose also, again, given what we've learned today, is be aware of your data structure. So I'm creating patterns that include node labels and relationship types. You don't have to include those node labels and relationship types. You can just keep queries open, but you will significantly impact performance by doing that, because you're returning more data. You're not being specific about the data that you need. So yeah, based on what we've learned today, I think those are the 3 things that I would point out.
Yeah, and if you come from a relational background, don't worry or to inverted commas break things by doing things completely differently. If when you work with a graph database, it's okay to do that, and I think it's even encouraged to do so. So don't just copy and paste your structured SQL queries and get them into a graph. Try to open your mind a little bit to how the structure is different, and how then the queries are different as well. Cool. One more from Mabel. Mabel asks, and I'm not sure I understand the question correctly, but maybe how can I convert a line in a numeric line in the query box?
I mean, Mabel, I don't know, because I'm not entirely sure I know what you mean. Perhaps if you could rephrase that question, or give an example of the sort of thing that you're trying to achieve.
Yeah, that would be helpful.
Yeah.
So sorry if we didn't quite get what you wanted here. And then this is another deep dive, so I don't think we want to go very far into it. But Dietmar was working with RDF type data, and wants suggestions on how to work with RDF type data in Neo4j. Can you just does it work out of the box? What do you need to do?
I mean, yes, it does work. I think the best thing I can tell, and I don't want to get drawn into a rabbit hole when we're in this sort of fundamental session, is we'll find the right place in the documentation, and I think we'll give you that link as a place to for you to go and find out more information. That feels like a very deep rabbit hole that we could go into right now.
Exactly. That's all the questions we had for now. But again, if you have more questions, just use the Q&A panel, and we'll go through them when we have time.
Okay, great. So shall we have a look at the challenges that we give people? Find a movie you like. If you run that Cypher, you will get back a list of nodes, which let's just do that. Share this tab instead. So we're going to match movie return m.title. And we get back a list of, this matches all of the movie nodes and returns all of the title properties for those nodes. I'm going to pick Jumanji as the movie that I like, because the questions I asked was use the acted in relationship to find who acted in a movie, and I can do that by running this query. So we're going to say match the movie nodes, use the title property to filter on the movie title Jumanji, and then use that acted in relationship to find person nodes. And if I run that, I get back a list of 3 people who were the people that acted in the movie Jumanji. The final question we set was use the directed relationship to find a relationship to who directed the movie. So let's just modify this. And again, the only change we need to do here is we need to change the relationship type. So instead of using looking for person nodes that have an acted relationship to the movie, we can find the director as well, who was somebody called Joe Johnson, which is a piece of information I did not know.
We still see the slide.
Sorry, I'm not showing the right tab. There we go. Yep. So we can use that directed relationship to find the people who, the person who acted, who directed the movie Jumanji, which happened to be Joe Johnson. Okay. Right. So let's go back to our slides. So we have spent some time looking at how we, sorry, excuse me, terrible cough today. Spend some time looking at how we read data within Neo4j, and we've been using that match clause. Let's look at how we write data within Neo4j. So the way that you write data is you essentially define a pattern that you want to create within the graph, and you use the merge clause to create that pattern. So in this case, the pattern that we're looking to create is a node that has a person label that has a name property called Tom Hanks, a name property that's equal to Tom Hanks. And we can use merge to create any pattern of data, pattern of data that we want. In this case, the pattern's really simple. It is just a singular node, a node with a particular label and a property. What merge will do is merge will look to create this pattern if it doesn't already exist. So when running merge for the movie, so running merge for movie title Toy Story, if that pattern already exists in the graph, it will not create a new one. It will just merge whatever data has also been defined. There is a keyword called create, which will always create a pattern, but almost always merge is more helpful to us. We can also use merge to create nodes and relationships. In this case, we're creating a pattern which is the person node Tom Hanks that we just created, the movie node Toy Story that we just created, and a relationship which is acted in between those 2 nodes. Once we have used merge and we've got a reference to the variables, whether that's P for Tom Hanks, M for Toy Story, or R for the acted in relationship, we can use set to create additional properties on those nodes. So this particular query is going to create a person node with a name property of Tom Hanks, create a movie node with a title of Toy Story, create an acted-in relationship between the two nodes that have just been created, and set an additional roles property on the acted-in relationship that will be equal to Woody. So that is how we do it. Let's have a look at how we actually do that. All right. So let's go back to console, share this tab instead. So let's create a new query. So the first thing I'm going to do is I am going to create a person node for me in my database. And the way that I do that is I say merge. I want to merge in a new pattern. And I'm going to create a node that has a person label. And I want the name property to be Martin. O'Hanlon, which is my name. Interestingly, using merge and create clauses, I can actually return the data as well, so I can see it once I have created it as well. So I'm going to merge this node in, and if I run that, we get a new node in our database that has a person label that we just created, and it has one property, which is name, which is what we included within the pattern. I could also, for example, say, add to this query and say set, I don't know, what should I set? Bio, technical curriculum. This is my role at Neo4j, at Neo4j. Right. If I run that, again, it returns me the node that's just been created and includes an additional property, which is bio. Okay. So all good. It's a good start. We can now create new nodes within our database. I'm a big fan of the movie GoldenEye. So what I want to do is I'm going to say that I directed the movie GoldenEye. So I'm going to create a second node called, which is going to be a movie node. I'm giving it the reference GE for GoldenEye, and I'm going to give it a title property of GoldenEye. So my query now is going to create or merge in two nodes, one for me, one for the movie GoldenEye. And then if I want to create a relationship between them, again, I use the same pattern, which says I want to create this pattern, which is me, the mode M. And I'm going to say create a relationship that has that is directed to the movie GoldenEye. I'm just going to give that a variable as well, just so I can return it, so we can see the results. So MDGE. So what I'm going to get now is I'm going to create a person node, I'm going to create a movie node, and I'm going to create a directed relationship between those two. Run my query. Great. I get what I expected, which is there are now two new nodes within the graph. They have the properties that I expect them to have. Martin still has the bio property. I haven't changed anything. I've used merge, which has, it would only create that pattern if it didn't already exist. And I've created that directed relationship to GoldenEye. So we end up with me as a node who directed the movie GoldenEye. And again, if we do a quick match query, person name, we should indeed find me. And I can just return that node as well. Here I am. And again, if I expand the relationships, we can see that I did indeed direct the movie GoldenEye. So we have got another opportunity for you to have a go. And again, I've got a series of challenges. which is I would like you to use merge to create a person node for yourself. And again, same pattern. What we're going to be using is I've given you the query. You need to fill in the blanks. So create a person node for yourself. And then I want you to give yourself a role in a movie by creating an acted in relationship. Any movie you want. And you set to create the role that you played within that movie. And set will create a property on the acted in relationship. And then I want you to use the match query to find the data that you just created. Okay. So, Alex, should we do some questions?
Yes, let's do some questions. We have one from Lucille. Lucille asks, ORDB suggests the directed and acted in relationships. Is this because there are constraints in the database, or how does ORDB know?
ORDB is essentially doing, code complete. There are no constraints. It's a really interesting question. Let's break it into two parts. What ORDB is doing is providing you with tools that allow you to auto-complete your query. It's doing that by querying the database to say what relationships exist and then providing you with a list. It's just a productivity tool, and it's being helpful to you. Let's talk about constraints, because that is a more interesting question. I just need to grab a bit more water. There is no constraints within the database. Interestingly, when you create a Neo4j database in its sort of default state, it is entirely schemaless. You can create whatever node labels you want, whatever relationship types you want, and you can create whatever properties against any node and any relationship that you want. And relationships and nodes don't have to have the same properties. So, for example, a person node doesn't always have to have a name, a bio, URL, in the same way that a movie doesn't always have to have a title. The properties that you store against nodes and relationships are up to you. And it is a very, very flexible model that allows you to create, dynamic data structures. If, however, you want to create constraints, and I actually think in the data that we've loaded, the constraints that exist are, if you create a node with the label person, it must have a name. And I think the same exists for movie and title, because both name and title are indexed. So we have created indexes. But by default, it is entirely schemaless. You can store whatever data you think is appropriate to whatever node label, and nodes can have multiple labels and so on and so forth.
Cool. Because you mentioned it, are we talking about indexes today? Because I think that's another, we talked about best practices, Cypher best practices. I think generally, database or probably any database really.
I don't have a slide, but we will point it out.
Point it out, okay.
Yeah. Okay.
Super.
Okay. All right. Let's go through these queries.
All right.
Okay. So the first one is create a person node for yourself. So I might as well let's just do that. So let's share this tab instead. Before I started this stream, I wasn't coughing, and I don't believe I had a cold, so I don't know what's happened. This is the syntax that we would use, and I've realised that smart quotes have been copied in for me, so I'm just going to change those to normal quotes. So if I wanted to create a node, I express a pattern, and I can optionally return me or not. If I don't return me, you run it, and it says, created one row. If I go back and match, we'll find that it has there. I do tend to return the data that I have created. I think it's a useful kind of mechanism to see the data that's been created as part of a merge clause. Certainly, when you are learning. So our second challenge was so to give yourself a role in a movie by creating an acted-in relationship and additionally set a role. So let's nip back to here instead. So I'm going to where's mine? Oh, dear. Merge. So I'm going to create me. I'm going to create the movie Twister. And then to create that acted-in relationship, I need to reference the two nodes I've just created using merge. So I'm going to say me, I acted in the movie Twister, and I want to additionally set a property against a relationship, which is the role that I played. In order to do that, I need to give that relationship a variable. I'm just going to call it R, because then I can say set R, give it a property. So role. I'm going to say I played myself. Why not? And then finally I can return me, R, and TW. So if I run this query, what I get is I get Martin. So this is the node that I just created, acted in the movie Twister, role himself, and again I get a movie node called Twister. And I can go through the process of creating a match clause to find that. Like let's find me as the anchor node. Let's use the acted in relationship to find the movie nodes. And interestingly, I've been a good Cypher developer, and I've been expressing labels, but again, I don't have to if I don't want to. Me. Oh, I need to give a. And again, it will return all of the nodes that have an acted in relationship. And interestingly, I've taken another shortcut here where I haven't given the direction of the pattern. A direction of the relationship. All relationships in Neo4j have a direction, and I would do that. However, if you don't include the arrow, Cypher assumes that the pattern goes left to right, so that every relationship goes left to right. It's the equivalent of doing that. And just to kind of prove that if I was to put the relationship the other way around, I would get nothing back. Right? There is no set of nodes and relationships in the database that match that pattern, because relationships only go one way. Okay. Right. So let's go back to our slides. I think we are just about to move on to a new section, Alex, where we start talking about data modeling. Should we do questions just before?
Yeah, I was just thinking we could maybe do a quick segment here. One comes from Khadija, and they ask, does create or using create, does it create duplicates if a node already exists, or does it overwrite the existing node?
It creates duplicates.
Yeah. All right.
Merge would overwrite the existing node. So let's say we use this pattern to merge a person in with the name Martin. If I then set additional properties, it would overwrite those properties of the existing node, because I've told it to merge this new information into the database.
Cool. Mike asks, what is the proper way to create a new line rather than to have run a query? I guess when you are in the query editor and you don't want to execute directly, I think it's Shift and Enter, and then you.
Yes. So yeah, Shift and Enter to run a query. Yeah. Or is it control and enter? I'm going to find out. Let's find out. It's control and enter.
It's control enter. All right.
Control or command and enter, presumably if you are
Yeah.
if you are on a Mac.
Yeah. And then one general question from Graham: the movie model is great, so to demonstrate how it works, but for him, he's interested in archives, documentation, physical objects where unexpected relationships may exist and they're revealed, and it can be revealed by this model, but he is unsure if it's a good fit. What is the most complex and perhaps unexpected real-world instance you can share with us? I think I can point you to our customer stories. And I'll share a link with you with that, where you can find all kinds of use cases, from fraud detection to recommendation to knowledge sharing, knowledge management to network management. I mean, it's pretty wild. So I'll share that link with you. I don't know if you have any pointers at Martin.
I mean, I was sort of struck by the complex and perhaps unexpected real world instance. I think one of the things where, if I think about unexpected, is where we have used automated processes. Maybe that's through a large language model, or to find entities and relationships within existing data, and then you start to find relationships that you didn't know exist. That's a really interesting one use case, when looking at kind of knowledge graphs and particularly generative AI applications.
Totally. And here are the links. I'll share this in chat as well, so everybody can, maybe it's interesting for everybody to see. But yeah, that's there for you all. And there, I think we can continue.
Okay, all right. So we're still on my. I'll find my mouse pointer. Okay, great. So let's move on. Okay, so let's talk a little bit about data modeling, because what we're going to do now is we're going to look at importing some additional data into our graph. So the sort of the golden rule when we talk about data modeling in graphs is this idea of noun, verb, noun. So person, purchased, product. Noun, verb, noun. Object, action, object. But you may need to kind of like expand on this idea, right? So we've got person, placed, order that contains product. So depending on how you are looking to describe your graph or describe the data within your graph, it's important that we keep that golden rule, and where we do need to include detail, we're not worried about doing that. So, I mean, just as a sort of person here, a sort of example here is we have person, placed, order contains product. That works perfectly well, but there would also be nothing to stop us within this graph creating a purchased relationship direct from person to product as well. But it is important that we sort of like know when to kind of break this golden rule as well. An order containing multiple relationships to lots of different products, and perhaps for example, other people who have placed orders for those products as well, and when we have that golden relationship of noun, verb, noun, it allows us to structure our graph in a way that makes our data easy to understand. Okay, so properties. And we spoke about this kind of briefly before, and I just want to kind of just re-emphasize it, which is properties don't have to be the same for nodes and relationships of the same type. So we have two examples here. Martin and Alex lives in the UK, lives in Germany. I have a last seen property. Alex has a purchases property. I may have never purchased anything. Yeah, Alex may have never logged in, and that is entirely possible to do with Neo4j, and in some cases, or in a lot of cases, desirable to do. You only store the data you need, and your data model is flexible to change. If you've used relational databases for a long time, I am sure you have found yourself in the position whereby, oh, I need to add another field to this table. Yeah, and I need to think about, actually, how do I pre-populate that data across all of my other records as well. Neo4j sort of by default is schemaless. Okay, so let's so those are the kind of first things I want to say about sort of data modeling, because what we're going to do now is we're going to look to import some additional data, and it is sort of important that we understand those sort of golden rules. Okay, so let's do some data importing. So I'm going to go back to Aura. So here's the query I was just writing. Now, right at the start of this workshop, we imported a data model, and it looked like this, and that's how we got our data in our database and allowed us to write queries and kind of see the data. What we are going to do now is we're going to add an additional node and an additional relationship to this data model. So this is import or data importer. We tend to call it both those things. And this is the model that we started with. And data importer is I'm going to call it a data visualization and sort of low code or zero code tool for importing data, typically from tabular structure, whether that's a relational database, or in the case that we're using, some CSV files. And we can create new node labels or new nodes. And that's exactly what I'm going to do. So the data that we are using, I think I might have to zoom out just so I can see. Yeah, I got to zoom out a little bit just so I can see. So if I zoom out just a little bit, I can see all of the files that have been imported, and we'll see right at the bottom there is this rating file, ratings.csv file that we can see. But we used all these other files to create this data model, and I think I've actually managed to delete part of my data model, so I'm just gonna reopen it. Yeah, okay, that's better. But we can see right at the bottom there is a ratings.csv file, and we can use that data to create ratings about ratings of movies. So what we're going to do is we're going to create a new node and a new relationship. The new node is going to be the user who rated, and that's going to be the relationship, rated a movie. And we can see in the data that contains in the CSV file, we've got some IDs. So we've got a movie ID, which is the ID they rate, the movie they rated, a user ID, their name, and then what rating they give it, and also a timestamp. So the first thing I'm going to do is I'm going to add a new node label. So it creates a new node within the model, and this is the model that I'm looking to import, or in this case, extend. I need to give it a label. So what label do I want these nodes to have that I'm going to import? So in this case, I want them to have the label user, and I need to select a table. So the table in this case being the data source, and we saw it's that ratings.csv file that contains the data for the user ratings. So I've got a label and I've got a data source. What I also need to do is I need to add some properties, and I can do that by mapping from the data source. So I say, okay, well, map from the data source. Which properties do you want to store against these nodes? Well, I definitely want the user ID. I definitely want the name. And I think that's it, because I could import the rating. So I could import the rating and store the rating against the user's node. However, if we think about graphs and we think about how we store data in nodes and relationships, actually the rating data I'm going to store against the rated relationship. I'm going to store the data of what rating they gave a movie actually on the relationship, not on the node. So I think that's all I need. I think, for the user node, I just need to know who they are and what their ID is. So I have added that in, and in the import tool has said, okay, well, I'm going to create a property called user ID, and I'm going to create a property called name. It has used the data that's within the CSV file to say, okay, well, what type do I think it needs to be? And it's suggested some types, but I could change them to strings, floats, booleans, date times, whatever. And it's also said this is the column, also the column within the data source that I'm going to get that data from. The other thing it's done is it has selected an ID. So this will be the unique ID for that label. But I could change it. And again, when I mapped the data, the other thing it did is it created an index and a constraint. And it's done that based on what I have defined, or what it's defined for me in this case, the ID for this particular node label. So in this case, it has created a constraint that says if a node has a label of user, it must have a user ID, and that must be unique. And it creates an index to allow me to search on user IDs as well, or search quickly on user IDs as well. Okay, so I have a new node now. It's at the moment it's a node that's sort of just hanging in the graph. It's not connected to anything. It's not a huge amount of help to me. But what I can do is I can create a relationship, and the relationship I want to create goes from the user to the movie. And using import, the way that I create a relationship is I just sort of hover on the edge of the node, just so to highlight it, and then I drag that and say, okay, well, I want the relationship to go to this node here. And I've created a new relationship. And if I select the relationship, you say, okay, well, you need to give a relationship a type. In this case, I'm going to say the type is rated. That is the relationship that I want to create between user and movie, user rated movie. And it's again, where is the data that exists for this relationship? Okay, well, it's in that ratings.csv file. And I need to map the node ID. So I need to map from the source node, in which case the user node, to the target node, which is the movie. And it's saying, which nodes do you want to do that? So in this case, it's going to be the user ID. So that's the ID in the user node. And where do you want to map it to? I want to map it to the movie node that has this movie ID. We also said that we would store the rating that the user gave that movie against this relationship. So I can add some properties as well, and I can use the map from table feature, which is a useful one. So I'm going to include the rating, and I might as well include the timestamp as well, which is when they made that rating. It's useful information, and I can confirm that. And I don't know if you've noticed, but as we've been kind of going through, data importers put little ticks against things when it has all the information that we need. And we now have a green tick against our rated relationship and a green tick against our user node. So I'm in a position now whereby I can run this import again, and it's going to create this data. And going back to what we learned about merge, is it's not going to create all new nodes for persons and movies. It's going to use the same merge process that we saw before, and it's going to update nodes if they exist. So I'm going to go ahead and run that import.
And maybe while we're on this view, I think there's a question from Lucille, and I think it's a good question to look at in terms of understanding. the question is why
Mhm.
use movie ID rather than the node ID for defining this in the importer?
I mean, the simple question to that within the import is that the movie ID is the only ID that exists in the source data. So I'm taking the source data and mapping that to the graph.
Yeah.
That's why I'm using movie ID. If my source data included a GUID of some description or a UUID of some description, which was a node ID, I could use that. But my source data only includes movie ID.
Exactly. So we're coming here from a CSV file. That's why there's no node ID that exists.
Yeah.
And then the other point on data importer is changing because you can change the variable type, string, integer, others. Does that have any implications, for example, storage or performance or others?
So there's a couple of questions there. Does it have an impact? Yes. Different data types have different storage requirements. However, my overriding advice will always be use the data type that works for your data. Don't try and force something into a different data type just simply because it saves you some a little bit of data storage. So yeah, it does have an impact. There was a second part of the question. I can't remember what it was, Alex.
Does it have any? No, I think this was it.
Oh, okay, right, yeah. I mean, the other thing I wanted to mention, I've remembered what I wanted to mention is data importer will do its best to convert data. So, for example, if you've got numbers in your source data and you've said put it to a string, it will convert it to a string. But obviously, it can only go so far. And if you've asked it to store properties as integers and you've only got strings, it won't convert that. And what you'll end up with is it will still run the import, but you'll end up with nodes that don't have properties. If it can't convert from one data type to another.
Cool.
Okay.
Thank you.
All right. Right. So I have run that, and now we have some user data within our graph. So let's, in fact, before we let's just put back before we share this. We'll just share this tab instead. I just want to show you. So let's actually just have a quick look at that data that we've just imported. So if I match a movie node, and I'm hoping it's a movie that's got some ratings against it, Toy Story, and let's use that rated relationship that we just created, rated, to find the users that rated the movie Toy Story. So I'm going to return are you. Typical. What have I was talking and thinking, talking and typing and not thinking. I've sort of mixed up my. Oh no, hang on. Sorry, apologies. Rated user. This is why you don't go off script, but we'll have a go. Let's go and find. Oh.
You mistyped limit.
Oh no, yeah. And all of a fluster. Right, so that's better. So these are users who have rated. In this case, what I've done is I've written a quick query here that returns all of the movies, all of the users who have rated movies. And what I've done is I've just limited it to the first 25 nodes. Let's do the first 100, and they're all movies for the single movie Toy Story. But what I don't understand is why my query didn't work. It's going to be something simple now, isn't it? Okay, right, fine. So this is the graph of users who have rated the movie Toy Story, and we know that we stored the rating of the rating against that rated relationship. So we can see for the movie Toy Story, these are the users who rated the movie Toy Story and the ratings that they gave that movie. So again, we can see that that our data import did the things that we wanted it to do. All right, let's get back to our presentation. So let's just spend some time thinking about answering questions and writing some more complex queries. So let's say we have this question, which is slightly specific. What is the movie with an actor called Robert? So let's go through the process of actually using Cypher to answer this question, and we're going to start by we'll sort of break it down. So the first thing I'm going to do to kind of like break this question down. So what is the best movie with an actor called Robert? So the first thing I'm going to do is let's write some Cypher to do that. So I'm going to share this tab instead. The first thing I want to do is I'm going to say, well, okay, well, match. I know we need to match, and I know we need to match person nodes. And I want where the name contains Robert. So we've introduced something new here. So we've seen where filters before, but I've introduced contains, so I can say where the property contains the word Robert, return P. So if the name property contains the word Robert, I want that person. So I've got Julia Roberts, I've got Robert LePage, I've got all sorts of other people. It doesn't feel quite right. So let's just do starts with instead. So I can use starts with as well. So I can say, okay, well that feels better. I'm not sure Julia Roberts is really the right person to have. If I'm looking for the best movie with an actor called Robert, but yeah, that feels better. So I've now found people called Robert, and now want to find the movies that people called Robert acted in. And again, we've seen that before. I can use the acted in relationship to go off and find the movies that people called Robert acted in. And actually, so let's keep with the graph for a moment, but we'll turn it into some tabular data in a minute. Okay, so now I've got a graph that shows me people called Robert and the movies that Robert acted in. Okay, that's a good start. So let's just change this to return some tabular data instead. So now let's have a list instead. It's a little bit easier to work with. So going back to my question, what is the best movie with an actor called Robert? Now, in order to work out the best movie, I should probably look at the people who rated movies with Robert in them. So again, we can use that. We can use our relationships to help us find that data, and we can use the rated relationship that we just created. So now I'm going to go off and find the users who rated the movies with the people that rated movies with an actor called Robert. So now I get more information. So I'm starting to kind of build up my graph, and obviously I've now got multiple relationships with multiple ratings for multiple movies. Let's just have a look at. So I don't really need the names of the users. I'm not that interested in that. But let's start to think about, how do I start summarizing this information? How do I start doing aggregation? So first of all, let's just have a look at how many people have actually, how many ratings for each one of those movies do we have? Okay, so that's good. So, you know, for Robert De Niro film Heat, we have 104 ratings. That sort of feels helpful. So we should be able to start to work out actually what's the best rating here. What's the best movie starring somebody called Robert. So again, I'm returning tabular data. If you're used to SQL, I'm sure you'll understand as. So, you know, I'm just going to tidy up my data a little bit and say, you know, as which Robert, as movie title, as, you know, rating count. Okay, that looks a bit better. But what I should probably also do is, I'm just formatting my query just to make it a little bit easier to read. Let's also create the average for each one of those ratings, and to do that, I can use the average function. I can use the average function, and rather than counting them, I'm going to take the average of the rating and average rating. Okay, so now I have which Robert, the movie title, how many ratings they got, and then what the average rating is. So it feels like we're nearly there, but it's not ordered particularly well. So let's order that by the rating average, and we want that descending because we want the best one first. Okay, so based on the data that we have, going back to the question we asked, what is the best movie with an actor called Robert, with an average rating of 4.02? It is Richard III, which starred Robert Downey Jr. Let's just recap what we have done here. We've used concepts that we have seen before. Sorry, I realize we should probably have made this a little bit bigger. Whereby we have used match to find a pattern in the data. In this case, we are looking for people who have acted in movies and users that have rated movies. We've used a where clause to filter that data. In this case, we are looking to filter it just by the person nodes to find people called Robert, where the name property of the person starts with Robert. And then we've returned some data. So first of all, we've seen this before, we've returned the person's name and the movie title. Now we move into new features, things that we haven't yet discussed before. We have used two aggregation functions. In this case, count. So this is the number of ratings, and average, which is being the average of all of the values that were returned. And again, if you're kind of like familiar with SQL, this will feel sort of similar to using group by. However, within Cypher, you don't have to specify; it is implicitly known. So we are and then using counts to count the number of ratings, using average to create an average rating, and then finally we are looking to order our result set. So we are looking to order it in this case by the average rating. So that's the average number of rating. But again, you know, if I wanted to change that to order it by the person's name or the movie title, I could change the value that I was looking to order it by. So in this case, it's by the Roberts, or again, that could be by the movie titles. So exploring what we've seen, whereby we're using pattern matching, we're using returns, and we've added in this concept of aggregating features. Okay, so again, I've got a little task for you to do. So we answered, you know, what is the best movie with an actor called Robert? I'd like to have a go. So I'd like to use the rating property on the rating relationship to find movies with the most ratings. And again, I've provided the majority of the syntax. What your challenge is to fill in the blanks, fill in the question marks. So find the movie with the most ratings, and we can do that using that rated property. And then find the top 10 movies based on average rating. Okay, so while I let you have a go at trying to do that and answer those questions, let's see if there are any other questions from people.
Cool. At the moment, I don't see other questions. So seems we have answered all the questions that there are or have had been. There were some questions on deeper stuff. So
deeper stuff.
Yeah, for example, Brian asks the where clause, does it support regular expressions, and things like that, which go a little bit further. But if you have any question in particular on any of the clauses that we showed here, or any of the functions as well, the Cypher manual is a great place to get an overview of all, how to use what, and some more explanations and basic to advanced usage. So I would say I would link to the manual here to give you that as a good way of reading on.
Yeah, I think one of the things that I would also point out is, I suppose, an extension to the Cypher language is also what's referred to as APOC. APOC is a set of I'm going to call them advanced functions that you can do all sorts of things with. I mean, the list is almost endless. But yes, if you wanted to search by regular expression, you can.
Yeah. I will also link to the to the APOC documentations, because I think that's also a good one. Do that in a second. Sorry, David. Yeah, I didn't see my screen was so big that I didn't think that we needed to zoom in a little bit. So I will make sure that for the remainder of this, we will zoom in a little bit more so that it's better visible for you all. You can always let us know if you should zoom in something. So sometimes it's a bit tricky to see. But yeah, I think that's it for the question. I don't know if you had any other pointers.
I did notice another one, which was from Thomas, which was apologies for the very basic question. That's fine. This is fundamentals. We're here to answer the basic question. How do you import data into Neo4j desktop? If you're using Neo4j desktop, you can use data importer locally. It doesn't have exactly the same feature set as Aura, but you can certainly import CSV files. The other thing I would say is, if you're looking for more control and more flexibility importing CSV files, there is a load CSV sort of Cypher clause, and you can use the power of Cypher to import your data. I would sort of point you towards a Graph Academy called Neo4j Data Importing Fundamentals, and there is also a more specific one which is called Importing CSV Data into Neo4j as well.
Yeah, super. That's a good pointer. I will share the link to Graph Academy one more time, also in chat, for everybody to see where to go next, basically, after this one.
Okay, so
Yep.
Okay. I was just looking to see if we had another question. All right, let's go back and look at the answers to these questions. All right, so the first one, movies with the most ratings, and what we're going to we are going to start with something, I mean, similar to what we to the kind of demo that I gave.
Yeah.
Apologies. Similar to the demo that I gave. Again, we are going to look to match some data, and we're then going to look to return the data. In this case, we're going to return the movie title, and we're going to use that count function to count the number of ratings and then order them by the number of ratings. And it happens to be Toy Story, followed by 7, followed by the usual suspects. In our relatively small data, relatively small data set. The next question we posed was the top 10 movies based on average rating. Okay, so let's spend some time actually looking at how we build up this query. All right, so we have a count of all of the ratings. So the first thing we need to do is we need to find the average, and I'm just going to very quickly change that count function to use the average function. So now we get L'America apparently has an average rating of 5, so that's good. If we want to, but we already, I mean, we could just look down the top 10 and say, there we go, that is the top 10 ratings based on average. Based on their average. If I wanted to limit the data that's coming back, and you saw me use it earlier, I can use that limit. I'm hi. Right. So this is what we had before. We're going to change the count function to average. And again, if I run this, what we see is a data set, and again we have the top 10. It's the top 10 rows, but we can use the limit function to limit the number of records or the number of nodes that are returned. And so by using limit 10, I get just the 10 records that I am looking for. So just the 10 that I am looking for. All right, I'm going to go back here. I'm going to say share this tab instead. Yeah. So that was how we completed these challenges. All right. So we're going to have a look at another question. So graphs help us understand relationships. And one of the things that we can do in graphs is we can use things like shortest paths to uncover new relationships that we didn't know existed. There is the how many steps from Kevin Bacon game, which looks to say how far away are you from Kevin Bacon, and actually we can use our graphs to do this. So the question I'm gonna try and work out is, using the data set that we've got, what is the connection? What is the shortest connection between Kevin Bacon and Al Pacino? All right, so let's start that. I'm just going to tidy up just so we can see what's going on. All right, so the first thing I need to do is I need to find Kevin Bacon within our graph. So let's just write a quick query to do that. So we're going to match Kevin Bacon. Again, really simple pattern to start with. I'm going to say find Kevin Bacon, the person Kevin Bacon, and let's just make sure he is actually in our graph, and we'll return it. Okay, so he is. There is a node that represents Kevin Bacon, and we can expand the relationships from Kevin, and worked out in this data set there is an accident relationship to Balto. But if I want to find the shortest path between Kevin Bacon and Al Pacino, I also need to find out Al Pacino. So I am going to again write a similar pattern that says find Al, who's a person. Let's cheat and do what all good software developers do and cut and paste. So now I have the graph that looks like this. So we can find Kevin Bacon, we can find Al Pacino, but there are relationships between Kevin Bacon and Al Pacino, and there's no seemingly direct relationship between Kevin Bacon and Al Pacino. But what I want to do is I want to find a path that actually links those two individuals. And there is a function called shortest path. And what shortest path does is it uses all of the relationships in the graph to find those shortest paths between any two nodes. So I'm going to use match again. And actually, what I'm looking for here is I'm not looking for a set of results. I'm not looking for a list of people names. What I'm looking for is a path, and that's what shortest path returns to me. So it's going to say shortest path, and I need to give it the path that I want it to follow. The pattern that I want it to look for. So in this case, I'm going to say find Kevin Bacon. Yeah. So from Kevin Bacon, find any relationship that gets you to Al Pacino. So that's the pattern. That's the pattern that we have defined. That basically says Kevin Bacon to Al Pacino. It's giving me a little bit of a warning because I've given an unbounded pattern. I've basically said, doesn't matter how long it takes you, just find me a pattern, right? We've got a small data set, and if I run that, hang on, maybe there is. Oh, so I was trying to just debug my query. The thing that I've done wrong is I'm returning Kevin Bacon and Al Pacino. What I should actually be returning is the path. I don't want Kevin Bacon anymore. I want the path between those two nodes. So now I get a path, right, that says Al Pacino acted in the movie City Hall, which was acted in with Bridget Fonda. Bridget Fonda also acted in Balto. Kevin Bacon acted in also acted in Balto. So what I can find is a paths between my data that I didn't know exist. Okay, so let's have a go at doing that ourselves. Again, I have got a few little challenges for you to have a go at. So we're going to use our shortest path function to find, right, the connection between the hardest critic and Kevin Bacon. Right. So our first job is to actually find who the hardest critic is. So the hardest critic is the user who was given the lowest average movie ratings. Right. And we can use that by, again, matching a pattern that takes us between users and movies, and then use that average function to find out who's the user that has the lowest average rating. And then once we have found that user, we can then use them to actually say, okay, well, what's the connection between the hardest critic, the person that gives the lowest movie scores, and Kevin Bacon? So that is the task that we are looking to do, and I'm going to give you a couple of minutes to do that, and we will answer any questions that might have come in.
Cool. There was one quick little back and forth here in chat about the differences between SQL and Cypher, or if there is a comparison between the two and others. I am not aware that we have a side-by-side comparison between
No, and I think no, I don't think it exists. I think if you're looking to make that transition from SQL into Cypher, or GQL, as in graph query language, of which Cypher is a superset of, is the key difference is understanding patterns in data. So moving away from this table, or from this collection of tables, joining on these primary keys and foreign keys, it's moving to that idea of expressing patterns in data. That represents the kind of the biggest shift, or the biggest sort of like mind shift. And again, it makes sense because actually, within a graph, we are looking and traversing patterns. We're not exporting or adding data to tables. That kind of represents the biggest challenge. But what I would say is, if you have a good understanding of SQL, and that idea of a declarative query language, you're going to find the transition to Cypher a lot easier.
Yeah, and if you are working with other, and then it's less about query language but programming languages, and if you're building your applications there, we have drivers with, for the most common toolage here, so you can get to use them from Python, Go, Java, JavaScript.net, and then there are other community drivers as well, or libraries like GraphQL or Spring Data. So you can keep developing in your own used to environment. You don't have, you still need to know some Cypher, obviously, but you don't have to necessarily go in via the Neo4j directly. Yeah, I think in the interest of time, we move on.
Okay, let's do that. Okay, so let's have a quick look at these questions. First of all, let's find the hardest critic, and this is a similar query to what we have seen before. So again, we're going to match a pattern of data, and we're going to use the average function to find who's got the lowest average. Tiffany Perez, half stars. Wow, she is difficult to please. But let's use Tiffany Perez to find, what is the shortest path between movies that Tiffany Perez has rated to Kevin Bacon. All right. So we're going to match Kevin Bacon. We're going to match that user, Tiffany Perez, and we're going to use that shortest path function again that says, find me a path between the node Kevin, using any relationship and any number of relationships, to the user, Tiffany Perez. And this is what it looks like. Tiffany Perez rated the movie Seven, which was also rated by Robert Brooks, which was also rated by Balto, which starred Kevin Bacon. And I think there's an interesting analogy here with other technologies. We're using movies and ratings. This could be customers and products as well. So if you're looking for, show me the products that somebody rated highly that somebody else might like, graphs are a really good way of exposing that data. Okay, so I just have one more thing left to say, which is you can learn more about about Neo4j, about graphs, about Cypher, and about how we use this on Graph Academy. It is completely free. You will find lots and lots of hands-on courses. Fundamentals, ciphers, drivers that Alex mentioned in terms of programming drivers, graph data science, and a free certification program as well. Everything that you find on Neo4j Graph Academy is free, and is free to take right now. Alex, I think I am done, which gives us a few minutes for any last questions if we have any.
Cool. Yeah, I think that's a great end point. I just wanted to recap. Obviously, all the material will be shared with you, so that's something you can have a look at later on. The recording we will share as well with the link. So like Bogdan, who came in a little bit late, no worries. You can always watch this from the beginning and follow along. And if you then want to know more, want to go more hands-on, then the Graph Academy stuff is great to learn from all kinds of ways. So I think in this Python, SQL, Cypher discussion, so Gottfried mentioned the intermediate Cypher queries on Graph Academy gives a good next step. So I think, yeah, have a look at that, and look at these other courses that are available on the Graph Academy. If you're wondering what to do next in this kind of format, I want to point out that we are doing the next live stream that we are running on our YouTube and LinkedIn channels is happening tomorrow, building model native apps with Hypermode and Neo4j. So that's more of a, AI focused session. So that's going to happen tomorrow, 19th of February. The upcoming next virtual workshop we're going to do. And now I need to quickly jump into my calendar because I need to see when that is. And that is sometime in March and takes care of GraphRag. And my calendar doesn't open right now. So I'll have to send you this afterwards. I'll put it in the video description on YouTube as well. So where the next training is going to be, when the next training is going to be, March, sometime in March. I'm blanking right now. Sorry for that. And yeah, with that, I think we are at the end of this episode. Again, here, great links, Graph Academy overview, Neo4j Aura if you want to get hands-on, and our developer pages for everything, documentation, best practices, meetups, whatever else happens around the Neo4j world. You'll find it there. And yeah, with that, I'll thank you again, Martin, for spending the time, for presenting, for preparing today, and for obviously giving everybody a good view into Neo4j fundamentals and mix of hands-on and slides. And thank you everybody for participating today and for your questions, for your attention, and for hanging around.
Thank you. It's been great.
Cool. With that, I'll wish you all a great rest of the day, rest of the week. See you around soon in one of these upcoming streams, workshops, or otherwise at a physical location, at a meetup, or maybe at a conference.